Before scientists can test an idea, there's usually another problem to solve first. Who's going to pay for it? That single decision can shape what questions even get explored at all. Science has given us vaccines, computers, gene editing, and spaceflight, so this isn't a story about science being broken. It's a story about the system around science. Who decides what gets funded, who owns a discovery, who gets to see results, and what happens when a promising idea needs to leave a lab and become something real. That matters to us because quantum biology sits at the intersection of physics, engineering, biology, chemistry, and more. So for research that doesn't necessarily fit into just one category, having an alternate way to get funding can matter. And the Quantum Biology DAO is one experiment exploring another route. But first, it helps to understand what DeSci, or decentralized science, is responding to. A few hundred years ago, science was supported through a mix of wealthy patrons, universities, learned societies, governments, and scientists' own money. In 1665, the Royal Society's Philosophical Transactions became one of the world's first scientific journals and helped establish norms around communicating discovery, scientific priority, and eventually peer review. The modern American research funding system took shape a little bit later. Before World War II, the federal government played a relatively small role in funding research at U.S. universities, but the war changed that. In 1945, Science Administrator Vannevar Bush delivered Science: The Endless Frontier, arguing that the government should continue supporting basic research after the war. His report proposed a new federal science agency and helped shape the post-war research system, but it did not directly become the NSF. Congress created the National Science Foundation in 1950. NIH had earlier roots, but its external research grant program expanded drastically after the war as well. And that model does make sense. If you're spending public money on research, you want experts evaluating whether it's worth pursuing. And if somebody claims a discovery, you want other scientists to check that work. But DeSci points to a few places where that system might get stuck. Let's start with getting funded. In the fiscal year of 2025, NIH received about 42,000 applications in its R1 equivalent research grant category and funded about 5,500. That's a success rate of roughly 13%, and applying also takes time. One survey of US astronomers and psychologists estimated that a proposal took an average of 116 hours from the lead researcher plus another 55 hours from collaborators. And even after you submit, the decision isn't necessarily fast. The whole process can even take years. That's understandable when millions of public dollars are involved, but it can be a constraint to early stage or fast-moving experiments. There's also a basic problem of judging research before it exists. Established investigators, preliminary data, and ideas that fit into recognizable categories give reviewers more information to work with. Something genuinely new or interdisciplinary can just be harder to evaluate. DeSci's argument isn't that expert grant review should disappear. It's more that there should be more than one way to get a yes. Then there's what happens after you get funded. Academic careers depend heavily on publications and citations. A 2022 survey of more than 6,800 researchers in the Netherlands found that higher perceived publication pressure was associated with more frequent engagement in questionable research practices. This doesn't mean publication pressure causes every problem with scientific reliability, but it shows how the incentive system can influence research behavior. And reproducibility is a real concern in some fields. In 2015, researchers attempted to replicate 100 psychology studies. 97% of the original studies supported statistically significant results. Only 36% of the replications did. That doesn't mean 64% of psychology is fault, and reproducibility does vary from field to field. But it became a very visible example of why it's important to check existing findings as well. DeSci asks whether the system could reward something besides just publishing something new. Replication, peer review, data sharing, and even useful negative results. Then there's access. Research can be publicly funded, reviewed by a scientist who might not even be getting paid to review, and still end up behind a journal paywall. At the same time, results with negative or inconclusive results are less likely to appear in the literature. A Cochrane review of clinical trials found that trials with positive findings were about 1.8 times as likely to be published as trials with negative or null findings. That can distort the scientific record because we see more of what worked rather than what didn't. To be clear, DeSci didn't discover this problem, nor did it invent the solutions. Open access and open science have been working on it for years. And traditional institutions are changing too. Since July 2025, NIH requires covered manuscripts to become publicly available through PubMed Central without an embargo on the official publication date. That's important because DeSci isn't operating against a system that never changes. It's adding experiments to reforms already happening in science. And there's arguably one more bottleneck. What happens when an idea works? A promising academic result can be too early for a company or traditional investor, but already beyond the scope of the grant that produced it. That gap between discovery and something mature enough to develop commercially is often called the valley of death. Universities, governments, philanthropy, and venture capitals are already finding ways to bridge this. And DeSci is experimenting with another, letting communities fund research and, in some cases, manage rights in the resulting intellectual property. So what is DeSci actually doing? DeSci's current Web3 form began taking shape in the early 2020s. It builds on older open science and alternative research funding movements while adding blockchain-based tools for coordination, incentives, and ownership. It isn't a new scientific method. It's an experiment in the structures around science, how it gets funded, rewarded, shared, and owned. One structure DeSci projects sometimes use is called a DAO. We made a whole video on this and I'll link it below so I won't get too deep into the mechanics here. Essentially, a DAO is an internet-native organization that uses blockchain-based tools to coordinate things like a shared treasury or group decisions. Some use token voting while others use delegates, committees, multi-signature wallets, or a mix of on-chain and traditional structures. So what are people actually trying here? One group pays approved peer reviewers the equivalent of about $150 per hour, experimenting with paying for work academia usually treats as volunteer labor. Another group developed something called an IP NFT, which connects a blockchain token to legal agreements governing research, intellectual property, and data rights. The blockchain isn't magically creating intellectual property, let me be clear. Ordinary legal contracts are still underneath it. And science DAOs can pool money from communities and direct it into research. So DeSci is plugging new infrastructure into the existing science system, not replacing the science around it. And here's the honest part. DeSci isn't necessarily a finished answer to everything. It's early and humans have mixed opinions on it, unsurprising. Let's look at the good side though. Take Athena DAO, a DAO putting funding towards women's health research. It put $120,000 to study ovarian aging with a named researcher at a named university, funded because a community decided that that work mattered. And we've lived a version of this ourselves. In December 2024, our own token auction raised roughly $6.8 million, and we've since granted over $1 million of that to the Quantum Biology Institute to fund real lab work and bring on real scientists. But DeSci, as most things, has its own problems too. Token-weighted governance can give large holders disproportionate influence, participation can be low. There are also real tensions between giving communities ownership and making sure scientific expertise still matters when decisions are made. And because tokens can trade on open markets, prices can move even if they have little to do with the actual underlying science. DeSci has not established that these systems outperform traditional grant review, peer review, or technology transfer at scale. DeSci is simply too young to make that claim. And it has to keep answering one very basic question, which is, does this actually need the blockchain? You don't need one to publish openly, share data, or crowdfund experiment. Those ideas existed before DeSci. Where a blockchain can add something is a public auditable record of funding or governance when those activities happen on chain, programmable rules for moving money, or new ways of managing ownership. It cannot tell you whether an experiment is well designed or if a scientific claim is true. So probably a useful way to think of DeSci isn't as a replacement for traditional granting agencies, journals, and the like. It's just another layer around them. Another way for alternative or unusual ideas to find funding, and another way to reward the parts of science that might go unpaid. The system we already have has built amazing, extraordinary things. I'm not here trying to say that that system has failed. It's to try something else and see if we can add to it. Right now, that's still an open question. But for a question like quantum biology, which is what we're interested in, lives in this multidisciplinary area, we're really excited about it. We'll be taking part in it, helping shape it, and we look forward to what happens next. Again, I'm here representing the Quantum Biology DAO community. If you're at all interested in talking about decentralized science, decentralized governance, quantum biology, or anything remotely related to those categories, make sure to join our Discord community and make sure to subscribe to our YouTube channel for more videos. Thank you.